Hello everyone. So in this video we will discuss the question number 21 of GATE 2015. Which one of the following graphs represent uncompetitive innovation? So 4 graphs are present here. So now before answering it, we will first understand what is uncompetitive innovation. So in uncompetitive innovation, enzyme will bind to the substrate to form this ES complex, and ES complex, after the formation of the ES complex, inhibitor I will come and it will bind to form this ESI complex, right? So this is your enzyme. So in this enzyme, substrate will come and it will make a ES complex. Substrate will bind to this substrate specific binding site here to form this ES complex, and after that, only after formation of the ES complex, I will come and I have a separate binding site which is not same as the substrate. I and S are the separate binding site. So after the formation of the ES complex, I will come and it will bind to a separate binding site, right? So to make a ESI complex. So here substrate and inhibitors are not sharing the common binding site. They have different binding site, and from this ES complex, ultimately enzymes will be separated and substrate will be converted to product P. So if we will see the 1 by V versus 1 by S plot of this uncompetitive innovation, the equation is 1 by V naught equal to Km by V max into 1 by S plus alpha dash by V max, where alpha equals to 1 plus I by Ki. I is the inhibitor concentration and Ki is the equilibrium constant of this reaction. Es plus I equals to which will lead to form the ESI. So in this reaction, the equilibrium constant is Ki. So if we will compare with this y equal to mx plus c, then m or equal to slope of this straight line will be Km by V max, right? Because if you will compare with the y equal to mx plus c, then your Km by V max or slope equal m or slope equal to Km by V max, and the intercept will be alpha by V max, right? So intercept will be alpha by V max. So this is in the presence of inhibitor, right? So in the absence of inhibitor, what is the equation? In the absence of inhibitor, the equation is 1 by V equals to Km by V max, or you can write it also Vm into 1 by substrate concentration plus 1 by V max, right? So this is when why? Because this is when inhibitor concentration I equals to 0. So if you can see that when I equals to 0 here, then alpha equal to 1. So at I equal to 0, alpha equal to 1, right? So in this case, that's why here in the case of absence of inhibitor, this alpha equal to 1, so the intercept will become 1 by V max or 1 by Vm, right? So if you will compare the I equal to in the absence of inhibitor and in the presence of inhibitor, the slope is same. Here also the slope is Km by V max. In the presence of inhibitor also, the slope is Km by V max, right? Here the slope is Km by V max. It is same. So as the slope is same, so in the absence and in the presence of inhibitor, the line will be parallel because slope is same. Now if you will see the intercept in the case of without inhibitor, when I equal to 0, then alpha equal to 1, then the intercept will become 1 by V max. And in the presence of inhibitor, when I not equal to 0, or actually when I greater than 0, then alpha will be greater than 1, right? When I greater than 0, then alpha will be greater than 1. So this specific term of intercept alpha by V max in the presence of inhibitor, that will be greater than 1 by V max, right? So 1 by V max is the intercept of the line when there is no inhibitor, I equal to 0, and alpha by V max is the intercept length when there is inhibitor concentration I greater than 0 in the presence of inhibitor. So intercept in the presence of inhibitor greater than the intercept in the absence of the inhibitor, right? So the 1 by V by 1 by S plot will be when there is alpha equal to 1, right? This line alpha equal to 1 means there is no inhibitor, I equal to 0. So in the absence of the inhibitor, this is your line 1 by V by 1 by S. When you increase the inhibitor concentration, right, then when you will increase the inhibitor concentration, then I will be greater than 0, and if I will be greater than 0, then alpha will be greater than 1. So in this case, the intercept length has been increased. You can see here intercept length has been increased, but the line is parallel because slope will be same, Km by Vmax in the presence of the inhibitor. Similarly, if you will increase I more, then alpha will also be increased, and then the inhibitor length will be increased. So in the case of this line, when the I concentration has been further increased, then you can see that intercept length has also been increased, right? But the slope is same. So lines are parallel. So this is the characteristic 1 by V versus 1 by S plot in the presence and in the absence of inhibitor in the case of uncompetitive inhibition. So now we can now check the options that so here in this case, option A, without inhibitor and with inhibitor lines are parallel, 1 by V by 1 by S lines are parallel, and with inhibitor the intercept length is more than the without inhibitor, right? Without inhibitor intercept length is this, and with inhibitor intercept length is this, right? So this length is more in the case of with inhibitor than the without inhibitor. So that means this is an example of uncompetitive inhibition, and lines are also parallel. Second option, see here intercept length is same, and also the lines are not parallel, so they can't be uncompetitive inhibition. Third option, intercept length has been increased with in the case of with inhibitor, but the lines are not parallel, so it is also not a case of uncompetitive inhibition. Option D, with inhibitor, without inhibitor, if you will compare, with inhibitor intercept length is more, without inhibitor with inhibitor intercept length is more than the without inhibitor, but the lines are not parallel, so it cannot be uncompetitive inhibition. So the option A is the correct answer.